corrosion. So corrosion is nothing but the oxide layer formation on a metal on exposure to air or and water. So metal becoming metal oxide, and thereby a metal oxide layer is formed over the metal, bare metal, and it will lose its property. The original luster is lost, and also there is a loss of material. For instance, we call rusting of iron as an example of corrosion. So why it is named as corrosion? You are losing the material. If you got a bridge without painting, in due course, due to climatic conditions, it may lose its material. So finally, the bridge may break. So we need to protect this metal from the rusting. So the prevention of rusting is very important. And before that, let us understand what is rusting and its electrochemical reaction. Rusting of iron, it leads to brown or black. Some dust formation over the iron. That is, iron becomes iron oxide. Iron oxide becomes ferric oxide, then ferrosulfuric oxide, then hydrated ferrosulfuric oxide. Likewise, it goes on, and finally you can have heavy corrosion, pitted corrosion, and there is a loss of material. Similarly, copper becomes copper oxide and it gives a greenish color. You could have seen in our puja vessels where you can find the greenish tinges on the copper vessels. Then aluminum is also getting corroded by the formation of white rusts. So that is aluminum oxide, Al2O3. Now let us proceed the mechanism of corrosion, and we should understand that the corrosion is nothing but an electrochemical reaction. Now when you talk about electrochemical reaction, you should have anode and cathode and finally cell reaction. So it means on the metal surface you have got the anodic site and cathodic site. So at the anodic site, iron becomes iron 2 plus with the loss of 2 electrons. So this is oxidation. So we have got the oxidation potential, which is given as minus 0.44 volt. In terms of reduction potential, it is given as positive 0.44. As I already mentioned, we adopt always what? The reduction potential. So you can get this value at standard state from the electrochemical series, where you could have got this value as positive because it is reduction potential. So since it is anode, it is an oxidation potential. So I have given this as oxidation potential. Okay. Then cathode. So cathode, at cathodic site, the carbon dioxide from air that combines with water, and thereby it becomes H plus and HCO3. Actually, this is not taking place at cathode, but in the atmosphere. Okay, and that is why we say carbon dioxide from air, and that can mix up with the water, and that causes the carbonic acid. So here it is bicarbonate anion and H plus. So this H plus triggers, and that is why we say overproduction and pollution by carbon dioxide, that causes what? Air pollution, is it not? That causes acid rain, and that is why even the marble buildings like Taj Mahal is getting corroded because of acid rain, where you got H plus. So likewise it will affect the metal surfaces also. So you got 2 H plus, so that is from the moistened air, is it not? So this 2H plus 2E becomes a 2H, and this 2H combines with that is oxygen, that becomes water. Are you able to follow? Now you can combine all this together as a single cathodic equation as 2H plus 2 half O2 plus 2E plus H2O. And now we have got the reduction potential, that is given as a 1.23 volt. Now we have to combine these two equations. What are these two equations? One is, that is anodic equation with the value of oxidation potential 0.44 volt, and cathodic potential is 1.23. Now we can combine this, so you are able to get cell reaction. So the 2E are cancel. Now we have got the Fe plus 2H plus R42 gives Fe2 plus H2O, and you can simultaneously add these value also. So minus 0.44 and plus 1.23. So in this case it becomes 1.67 volt. Okay. Now listen to me, that is here it is a 0.44. so take it as, if it is a reduction potential, you should be called as what? Positive one. Okay, so 0.44 plus 1.23 means you have got 1.67, right? So 1.67 volt. Now that is the value of this cell reaction. So it means this potential of cell is more than enough to corrode a metal, especially iron. And finally it will proceed further. This Fe2 plus, which is formed over the surface of the metal, that combines with oxygen and water to give or to aggravate the situation to become ferric oxide. So ferrous oxide becomes ferric oxide, and ferric oxide with the n number of molecules further to give hydrated ferric oxide. Okay, so this is called rust. So this is the mechanism behind the corrosion. Okay, so this is very important. So you should be aware of the electrochemical reaction, the complete mechanism with the two-step process and the final cell reaction, and also subsequent reactions carried out at the surface of the metal. Okay, that causes rusting. Now let us proceed. How to prevent the corrosion? See, the object is, the main enemies are here air and moisture, is it not? Air and water. So that has to be prevented. Okay, so that contact should be prevented. So the best way is apply oil or grease on the metal. That is one way. Another way is simply paint, so that you can prevent the metal from water and air. And you can galvanize. What do you mean by galvanize? Galvanize means, that is, you have got the molten zinc and that can be formed over the metal, and that is why we call it a GI, galvanized iron pipe. So there are various processes, electrogalvanization and a hot dip galvanization, etc. Okay, so this is the important topic in electrochemistry, the corrosion, and please make a note of it.